All right, well, this is the first time that I'm doing it this way, but we're going to cover confined spaces and compressed gases for this presentation today. So here's the thing about the confined spaces. You may or may not have these at your facility. I know Purity Zinc in Clarksville has theirs, and I'm assuming that Stony Creek has confined spaces as well. But then again, there may be some places that don't. But with all that said, who's to say at some point later in time that you don't get some new equipment that qualifies as a confined space? Or maybe you go somewhere else here in the future and they do happen to have confined spaces. So this is a pretty important topic to speak on and at least give everybody some awareness. And so that's what we're going to do here today. You can see my opening slide here, pretty much a classic situation for a confined space. Anytime you have to go down a ladder or through some sort of a manhole or portal situation like that, that's going to be a pretty clear giveaway that you're going to be in a confined space. Flipping over to our next slide. So a lot of people ask, what is a confined space? And I always tell my people, if you're in a conference room, I ask them, is this conference room a confined space? And they'll kind of look around and some will say yes, some will say no. But anyway, long story short, a conference room, if it's got a perfectly good door that you can walk in and out of and it's designed, like you see there at the bottom, for continuous human occupancy, then no, that would not be considered a confined space. But then you think of something like maybe a chemical tank or something like that. That would be, again, a good example of what a confined space is. So here's the OSHA definitions for both non-permit and permit required confined spaces. A confined space has to be large enough to enter and to perform work. It's limited in the way of entry and exit and not designed for continuous occupancy. And so here's a good exercise to start with. Is this a confined space? And I think I answered my question earlier. But yeah, this is a classic example of what a confined space would be. You can see there it's not meant for people to occupy, but yet you can get in there and work, but you have a limited means of entry and exit. So in case you were to get into trouble, it might be kind of hard for you to get out immediately. And so yes, now it depends, is it permit required or not? Of course, easy example here was, did that tank that we looked at, did it last contain just water, or did it have something kind of nasty in it like ammonia? And that would make the difference between, is it a permit required or not permit required? So you have to look at those spaces on a case by case basis. But yes, a tank like that would at least be a confined space. Just a matter of, is it bad enough that it needs to be permit required? And so our non-permit required confined space, that's a confined space that does not contain an atmospheric hazard, nor the potential to contain any hazard capable of causing death or serious harm. So a tank that held water and nothing else might very well be a non-permit space, but as you can see, of course, if it had ammonia in it, then that would be a completely different thing, and it would probably be a permit required space at that point. And our permit required spaces, of course, they have an actual or potential hazardous atmosphere. The internal shape could trap the entrant. So you've probably seen cases where tanks might kind of taper down toward the bottom. There have been many cases where people have gotten themselves stuck in that sort of configuration. They've actually died that way by being stuck, and they couldn't rescue themselves. Or, as you can see on this next slide, there might even be some materials in that space that could engulf the entrant. And a classic example of this would be like a grain silo. And the grain, a lot of times, can be so fine that it kind of acts like quicksand. But you can see here, kind of toward the bottom left, after about 10 seconds, you can be up to your waist. And at that point, it takes something like 300 pounds of force to get yourself out of that. And it doesn't take long to actually to drown in grains or dusts or anything like that. You can see the examples there where people have been avalanched on. People get in the middle and they wind up falling through. But these are all things you have to consider. in your confined spaces. There's other engulfment hazards, of course. Water, sand, sawdust, powders, and even gases are considered engulfment hazards. And you can see here pretty good danger label here on the side of a grain bin. Let's see here. More confined space hazards, and usually our biggest one that we're looking at is the oxygen deficient atmosphere. It's very common, unfortunately, for people to go into these confined spaces without their confined space air monitor, and they get in there and they're actually entering into a space that doesn't have enough oxygen to sustain life, and they wind up dying that way. Many terrible examples over the years. The atmosphere can even be combustible, whereas it's like somebody's in there working with some sort of solvent, or even they've got gasoline in there, and it's venting off and creating a combustible atmosphere where if there's a spark or a flame, it could cause that space to basically explode while people are inside. And then, of course, I think we've already spoke on toxic air contaminants, things like chemical vapors, especially things like ammonia, chlorine, things of that nature. Toxic air contaminants, of course, occur from previously stored material, or they could result from applying coatings, solvents, or any other chemicals while they're doing maintenance inside of that confined space. And here's a slide that I snuck in here the other day. This is kind of like a best practice on how to ventilate your confined spaces so that you're ensuring that you're getting fresh air. Your upper left-hand corner here, this air blower is pulling air and then venting that fresh air into this space. And then this other blower here is taking all that air up and then shooting it back out. So you've got a constant flow of fresh air in this confined space. There's physical hazards inside of confined spaces, typically moving machine parts that you have to consider, and that goes hand in hand with kind of your lockout tagout program and making sure that you've isolated the energy for those moving machine parts. Dangerous fumes or liquids, as we've already discussed. Even things like excessive heat or cold, especially if you're going into a confined space with a Tyvek suit on and it happens to be summertime. Those are very real hazards that we have to consider. And then excessive noise is another one, where you get into a confined space and you start using some sort of power tool or a jackhammer, or even using a hammer. That can cause really loud noises inside of that confined space. And so you need to consider, do you need to wear hearing protection or not? And then, of course, there's every other hazard that we really didn't cover, kind of our miscellaneous hazards. That's a pretty good example there of a space you wouldn't want to go into. So always keep those things in mind as well. Some statistics, just some random stuff from the OSHA website. Between 1997 and 2001, an average of 92 confined space fatalities occurred each year in the United States. And a lot of these are very, very preventable. I think OSHA came back and said that almost 100% of the time when someone died in a confined space, they didn't have an air monitor or a confined space permit or any kind of a program when they went into these confined spaces. So in theory, if you've got your confined space program, your confined space permit, and your air monitoring, then it's much more difficult for you to be hurt or killed inside of a confined space. And that's why we have these programs, is to keep you safe. And why we do this training, so that you'll be better prepared if you have to encounter a confined space on your work site. Here's an example of a fatality, and this is back in 2009. It was a triple fatality, and reading this, looks like a worker was overcome by hydrogen sulfide gas, which is a very toxic and very fatal gas. It's that gas that gives you that rotten smell, the rotten egg smell, I'm sorry. So this person was cleaning out, what was he doing here? He was cleaning out something there, and was overcome by the hydrogen sulfide gas, and he collapsed into the space. And then what I've underlined here is very important. He had two people go in after him and try to rescue him, and I assume they were just trying to hold their breath, or maybe they didn't even know to hold their breath, but they went in, tried to rescue, and they both wound up being victims as well. And so that was a triple fatality. And it says there, OSHA's inspection found that the piping company should have monitored the air quality in the well to determine the atmosphere that was in there before they went down in there. So it's very important to note, based on that example, we're never to attempt to rescue a downed coworker by entering a confined space ourselves. And many fatalities have occurred over the years, but because of would-be rescuers trying to jump in and hold their breath and trying to rescue that person. And it's a very difficult thing to have to deal with. It's bad enough that we've got one person possibly dead in a confined space, but then to send 2 or 3 other people in there after him, and then you wind up with bodies on top of bodies, and it's just a very tragic situation. So we have to remember that we're never to attempt to rescue a downed coworker by entering that confined space ourselves. And we'll cover more on that here later on what to do. And here's another quick example. This person tried to get into his tanker truck, and that chemical there, that alpha pinene, it was 99.2% concentrate, but the vapors were just too much. That person went in there and he was overcome and wound up dying. He didn't tell anybody he was going in there, and he would come up missing, and then they eventually found him, but it was already too late at that point. So air quality monitors, this is life-saving equipment. So if you've got permit-required confined spaces on your site, you need to have at least one air quality monitor. And the good thing about these air monitors, basically they're the 4 things that they typically cover are the 4 things that you're going to need to know about. And we're looking at what's the oxygen level, is it safe or is it not? That LEL, that lower explosive limit, that's looking at the flammability of that confined space. So is that a combustible environment that could explode? We're looking for things like carbon monoxide. We've all heard about the dangers of carbon monoxide, and then hydrogen sulfide gas. Those 4 things right there are pretty much industry standard that I've seen anyway, and those are there. If you got that monitor on you, that's going to be there to alert you if anything starts to get outside of the healthy zones, and that'll give you time to get out of that space. And so that's just kind of a picture here of the type of monitors that I've dealt with before. It's MSA Altair 4X. Your monitors may differ, and that's fine, but they all basically do the same thing. And I think this is on one of your quiz questions, maybe. The oxygen levels for a safe atmosphere, it's going to be between 19.5 and 23.5. So on your air monitor, if those ranges get below 19.5 or over 23.5, it's going to set off an alarm, it's going to buzz, it's going to scream at you. You're going to know that something's wrong and you need to get yourself out as quickly as possible. And typically in a fresh air environment, when I've got that monitor on, it's going to be showing me something about 20.8 or 20.9%. And that's pretty much where it needs to be. Now, keep in mind, if you're working with any gases like nitrogen, argon, carbon monoxide, those are all gases that displace oxygen, and that will start to decrease your oxygen level on your monitor. And then keep in mind that if you're doing any type of hot work in a confined space, the combustion process is going to be consuming oxygen as you've got that flame going. So it's perfectly natural for someone to go into a space and it be 20.8%, and then they start using a cutting torch, and then over time you can start to see that oxygen level start to decrease. And that's why we always say, if you're going to be doing any type of hot work in a confined space, then that space automatically becomes permit required because of that situation. Let's see here. And this talks about the lower explosive limit a little bit more in detail. If you've got a combustible vapor in that confined space, it can be low enough or weak enough that it's not going to ignite, and it can also be too rich so that it doesn't ignite. But there's this big zone right here, this combustible range, where if it gets into that, then you can have an explosive atmosphere. And that's what your LEL is monitoring. All right, so we're going to talk about our permit components. And if you have confined spaces, especially permit required confined spaces, you need to have a confined space permit in place. Entry into a permit required confined space is not a one-person job. It's going to take a team of people working together, and they're going to have the knowledge of the program and of the equipment used and of that space so that they can work there safely. And they're going to use that permit as kind of a structure or a guide on how to work safely. And of course, you have to be trained before entering into a confined space. So typically the places that I've worked, it's going to be your maintenance type personnel who go into your confined spaces, and they're the ones using the monitors and using the permits and all that stuff. And later on this week, I'm going to grab my my maintenance people here at Clarksville, and we're going to do a hands-on with the confined space air monitoring and get them familiar with all of that, so that they're more comfortable and more familiar, and they're going to be able to use that to keep themselves safe. So that's just an example of what a confined space entry permit might look like. Is provided by the employer and authorizes entry into a permit space. And so some components that it's going to list out would be the spaces to be entered, the purpose of the entry, what type of work are we doing, the date and the authorized duration of the permit, and a list of authorized entrants, as well the names of any attendants that we might have, and the name of the entry supervisor, what sort of hazards do we expect to get into or are potential for this permit space, and of course the measures used to isolate the permit space and protect the employees. It's going to mention acceptable entry conditions, and of course before we ever step foot into a confined space, we need to do our initial testing with the air monitor. That's typically where you would hold the air monitor in your hand and drop a little tube or a hose down into the space, and it's going to be able to monitor that space before you ever even go in there. And then your periodic testing, that's where a person goes into the space and they bring that monitor with them, and maybe they wear it on their belt, or they set it up on a spot inside of the confined space. And that keeps that constant monitoring going, so that if anything changes, then that alarm's going to go off and our people know to get out immediately. It's also going to mention the rescue and emergency service numbers, because remember, we don't go into a space to rescue anybody unless we've been trained, and that's a whole different topic. But typically what most companies do is they will contract out with the fire department or emergency medical services if they're close enough by. And I've had plenty of cases where companies will, if they're going to do a permit required confined space, they go ahead and call out a rescue group. And all they do is they sit there by the confined space with all their SCBAs and respirators and stuff, and they're ready to go in and rescue if something were to happen where somebody collapses in a confined space. And then it talks about communication procedures, whether it's verbally or by radio, or it could be even by flashlight, things of that nature. And then there's just some miscellaneous stuff, such as the equipment required, such as what kind of, do you need lighting inside the space, or is it going to specify non-sparking tools like brass components, things like that, things that don't spark. And then, of course, if there's going to be any hot work going on, then there needs to be a hot work permit. And if you're line breaking, you need to have a line breaking permit, things of that nature. On our permit system, the entry supervisor verifies the acceptable entry conditions. And keep in mind, if you are an entrant into a confined space, after you've been trained and gone through all that, of course you can observe the air testing as it's happening, and entrants can always request retesting at any time. That's kind of your right to know about the space that you're going into. Your permit system is, your permit is going to be posted at or near the entry portal. And the entry supervisor can cancel the permit pretty much at any time for any reason, especially if there's some unsafe condition that arises during the course of the work. And then the employer typically keeps the permit, the completed permits, for at least 1 year after cancellation. We have to keep in mind that a confined space permit is only valid for the length of one shift or until the task is complete, whichever comes first. So you're not going to start up a confined space permit and you're going to use that one permit for a whole week. No. If another shift is going to be coming on and the work still has to be continued, then that shift's entry supervisor will have to generate a new permit and new initial air monitoring data and pretty much start from scratch all over again. And we're going to look at the roles, starting with our authorized entrant. They, of course, are the one who enters the confined space. They know the hazards they can face. They understand the PPE and the equipment, how to use it, and they communicate with the attendant as necessary. They're going to alert the attendant outside to any dangerous situations inside, and they need to recognize the exposure symptoms. And they're to exit the permit space whenever evacuation is ordered by the attendant outside, or if there's a dangerous situation recognized or a prohibited condition is detected, or if there's any sort of evacuation alarm activated, and they need to go ahead and get out immediately. Our attendant monitors the activities inside and outside of the space, and they're supposed to remain directly outside the space unless they're relieved by another attendant. So they can't even go and use the restroom, even for just a minute. They have to have someone, another authorized attendant, come in and take over for them while they go and do their thing. They have to know the hazards that could be faced and, of course, recognize exposure symptoms for their people that are inside. That attendant maintains an accurate count of the entrants who are coming in and coming out, and keeping track of them, communicates as much as necessary. They know how to summon the rescue services, of course, and they protect the permit space during entry from unauthorized people from going in. And they are to perform non-entry rescues. So maybe you've seen pictures before of the entrants who wear a full body harness, and they have like a lifeline tied around to the D-ring on their back, and maybe they're connected to something like a davit arm or a tripod where they can crank someone out of that space if they were to get into any kind of trouble. And so that's a perfect example of a non-entry rescue. And our attendants may only enter the space if they have been relieved by another qualified attendant. Our entry supervisor now knows the hazards that can be faced. They verify the testing of the air quality. They know the procedures, they know the equipment, and they're going to sign off on that permit to allow the entry to begin. They can terminate and cancel the entry permit at any time. They verify that rescue services are available and the means to summon them is operable. They're to remove any unauthorized individuals from getting into the space, determine that entry remains consistent with our permit qualifications, and the entry supervisor will not allow employees to enter a confined space if initial air monitoring shows an atmosphere that is immediately dangerous to life and health. So if we lower that hose down into the space and we've got our air monitor in our hand and we start getting the alarm going off, then we're not to enter that. We need to set back and try to figure out how to better ventilate that space, or did we close off all the stuff that we were supposed to, but we're never going to put anybody into a dangerous situation. All right, so we're not going to worry too much about the alternate entry stuff. Let's see. And we were talking earlier about if hot work is going to be going on inside that confined space, then we can't reclassify it, even if it's a non-permit required space. If you're doing hot work, it automatically becomes permit required because flames consume oxygen. Welding fumes could be toxic. There could be an explosion risk. Understanding the possible signs and symptoms of hazard exposure while working in a permit required confined space is critical. So if someone is in a confined space and they start to experience any of these symptoms that are listed here, then that's a sign that maybe something is going wrong inside that space, and we need to reevaluate. Now, don't get me wrong, that person could just be coming down with the flu, but at the same time, worst case scenario, it could be that they're losing oxygen in there. So, whatever the reason is, we need to bring that person out of the space and figure out what's going on. But any of those symptoms that you see there could be signs of hazard exposure in a confined space. Just a quick slide on oxygen deficiency, and you can kind of see there. Once you get below that 19.5% range, that's when the work becomes hard, coordination is reduced, and then it goes down the line. The lower that you get in your air levels here, you eventually get to the point where you'll die. So look out for stuff where maybe people are having trouble breathing, or it's labored breathing. They're exercising poor judgment. Maybe their lips are turning blue. maybe they're turning pale, nausea, vomiting, all those things. If that happens inside of a confined space, we need to get that person out as soon as possible. Carbon dioxide, of course, is another thing. Now, your air monitor isn't going to typically monitor carbon dioxide, but with the presence of carbon dioxide, that's going to reduce the oxygen level in your confined space, and that's when your oxygen level alarm is going to set off. So just because your air monitor doesn't explicitly monitor a lot of things, typically if there's the presence of something in there, it's going to reduce your oxygen level, and that's what your oxygen monitor is there for. Carbon monoxide, which typically your monitors will monitor, that's the colorless, odorless gas, and you can't breathe it, and people die from it all the time. And there's a classic situation that happened a while back somewhere else here in the United States, but a couple of people went into a confined space, and they had their air blower outside the confined space, pulling fresh air and pumping it down into the confined space. But a person came up in their truck and parked their truck right there in front of the blower, and they left the engine running, and then that carbon monoxide from the exhaust was getting pumped down into the space with those people, and it set off their alarm, and they were able to rescue themselves, and they got up on top of the confined space, and they realized what was going on. So always consider those types of things. Your parts per million, just real quick. The thing about parts per million is the lower the parts per million allowed in the air by law, the more hazardous that substance is. So there's carbon monoxide. I think that legal limit is 50 parts per million. So imagine if you had a pegboard with, I don't know, say 1 million white pegs on it, kind of like you see there in that picture. If you had 50 red pegs colored red, and that would signify carbon monoxide, that's all that it would take for that space to be dangerous. So the lower the parts per million allowed in the air, the more dangerous that chemical is. And think of things like chlorine. They have a very low parts per million. All right. So yeah, and this kind of goes more into the symptoms and side effects of being exposed, and it's kind of pretty much all the same thing. But if you've got headaches, dizziness, nauseousness, impaired judgment, things of that nature, you're not coordinated, those are all signs you need to get out. Shortness of breath, tightness across the forehead, slight headache, or even a severe headache, vomiting, collapse, all these things are exposure symptoms to look out for. And then the other thing that your monitor is going to look at is the hydrogen sulfide, also known as H2S. Smells like rotten eggs. The dangerous thing about that is, and this is what sewer workers encounter all the time, but a person goes down into a sewer and they smell the rotten egg smell for just a couple of seconds, and then it seems to go away. Thing is, it didn't really go away, but the H2S has a tendency to numb your sense of smell, and that's what's so dangerous about it. And people carry on with their work, and they assume nothing is wrong, and before you know it, they're having trouble, and they wind up collapsing, and in worst case scenario, they wind up dying. And so your 4-gas air monitor, pretty much industry standard, is going to have a monitor for H2S on there. And then this is what I was talking about earlier as far as the non-entry rescue procedures. Classic example here, a worker with a full body harness, and then he's got a lifeline, and they're able to crank this person out by a tripod or a davit arm or something like that. And while this is happening, someone has already called the EMS to come on and provide oxygen, provide their rescue services. So keep in mind, we're not to do the entry rescue ourselves, as far as actually going into the space and trying to get someone out ourselves. There's a whole different section on that where it's advanced rescue training is required, and that's what it takes to be legal. So for pretty much 90 to 95% of your companies out there that have to deal with confined spaces, they either have an on-site rescue team or they've got an EMS service within about 5 minutes from the facility that can come on and perform rescue. Let's see here. So employers must select an outside service based on that rescuer's ability to respond and be able to function appropriately and be well equipped. Like I said, we don't want to rely on the EMS service if they're 15 minutes away from the plant. You know, they need to be pretty close to the plant. And our rescue procedures, employee-based rescue teams must be informed of the hazards they could encounter. They need to be equipped for and proficient in rescues, and they have to do their annual rescue simulations, and they have to have, of course, access to the space. So for non-entry rescues, which is the preferred way, employees should use retrieval systems consisting of the fall harness with the lifeline clipped to the D-ring on the back, and ideally with the aid of a davit arm or a tripod with a crank. And then kind of a distant second option here is these wristlets, but not a lot of people use those. They're not terribly practical. This picture you see here is pretty much ideal for what you want to do. And then I think this might be the last slide here. When coordinating entry with our contract employees, you know, they have to have their procedures themselves, and if they don't have any procedures, then they need to be trained at least to the host employer's procedures. So one way or the other, you know, they're going to have some sort of rhyme and reason and a structure on how they're going to work inside of a confined space. I've worked at companies before where these contract employers, all that they do is confined space entries, and they have very, very good programs and procedures. And if we deem that theirs are better than ours, then we'll let them go off of theirs. But if they don't have much of a confined space program or a permit system, then they have to abide by ours. So it's pretty much whoever's is the most comprehensive. So yeah, that's confined space in a nutshell. You know, people every year all over the world die in these confined spaces, and it's just a matter of training and getting educated on why these spaces can be so dangerous. So when you're out there, you know, in your workplace, you know, look around. You may very well have a number of confined spaces that have been labeled. But of course, if you're out there and you see something that looks like it meets the definition of a confined space and it's not labeled, you know, it's one of those things that we like to label all those so that we can inform our employers not to go into those spaces. So yeah, that's confined spaces. So I thank you for your time and your attention, and I think our next topic this month is going to become compressed gases, and so I'm going to pause this and get right into that. Thank you.